皆さん、こんにちは。私の発表はすべて英語で、本当に申し訳ございません。皆さん、頑張ります。僕もゆっくりで話します。The title of this presentation is The Selfish Programmer. And it's an exploration of what you can learn by writing software for yourself as opposed to on a team or part of a larger organization. My research shows that the three most important traits of a successful solo programmer are that they be antisocial, egotistical, and irresponsible. And we're going to talk about all three. Now, you may know me by this old picture that doesn't really look like me, or by Searls on GitHub and Twitter, which I pronounce as Saruzu when I'm here in Japan because it's a little easier. And I come from a company, Test Double. We're a consulting company. Our double agents join software developer teams to get things done, as well as to search for general ways to improve. I'm here today because I had a problem, and that's that learning Japanese is really hard. And I've been trying for years to learn Japanese, and recently, a couple years ago, I found an application called RubyKaigi that helps teach kanji and vocabulary memorization. Its interface is like a flashcard game. So you see Japanese, and then you have to provide the reading, like tsunahiki, and it marks you right or wrong, as well as the English meaning. So this means tug of war. And depending on my answer, it creates a timer based on when it thinks I should review the word again to help me memorize it. What I found was that this app's ability to teach me from Japanese to recognize what the English meaning was very good. I learned a lot of kanji. But when I was speaking in Japanese and I had a concept in English that I wanted to convert into Japanese, it didn't help me very much at thinking of the right word. And so I built a companion app to RubyKaigi that I call Kame-same, which is basically the exact same app, but in reverse. So it shows you an English prompt, and then using a Japanese keyboard, prompts you to provide the correct answer, and then it marks you right or wrong with a similar timing system. Additionally, I wanted to use this as an opportunity to learn how to use the flick keyboard correctly, and so I get lots of practice, and the application can survive lots of disconnects, and so it's a progressive web app. So Kame-same, building this app, taught me a lot about selfish programming, and I'd like to start to talk about why it can be good for a programmer to be a little bit antisocial. Okay, so world one, stage one. The selfish programmer is unambitious because it's easier to stay motivated when your goals are incremental and achievable. When goals are too ambitious, we run the risk of exhausting ourselves without really accomplishing anything, which might lead to us quitting and giving up. Work is different. At work, our apps are big. They have lots of different parts. Their operations are large and complex. And we work differently, where we can safely trust that somebody might work on this part of the application over here, whereas we can focus and specialize in a totally unrelated area. And the problem with large systems is that our brains aren't big enough to contain them. And so if we try to move from area to area, the context switching between them is really time consuming. And so what we tend to do is most people specialize in just one area at a time. And sometimes this leads to developers not knowing how other areas of their application work. And just talking about this makes me nostalgic for 2005 when I first started using Ruby. Because in my mind, Ruby became famous when it enabled individuals to make small and useful applications. And back then, I was much faster too, because Ruby enabled me to keep the entire application in my head. So that nostalgia got me excited to create a new solo Ruby app 14 years later. But even after several days of effort, I unfortunately only completed a small part of the app, and it was useless by itself. And I started to think about how much the rest of the application would take, and it just made me discouraged, and so I gave up. And somehow in that 14 years, I had unlearned how to make small, useful things. I had become too ambitious. So I instituted a one-weekend rule that if I can't release a project by the end of Sunday night, I don't even start it. And the one-weekend rule is a liberating constraint. It forces me to shrink the scope of my app. And it has the side effect of also fitting inside my brain, so I work much more quickly. So my first step was I tried to imagine the tiniest useful thing that I could make. And I decided on a gem to tell me whether my RubyKaigi flashcard reviews were ready or not. So it's a simple CLI, and you run it. And if they're not ready, it tells you when to come back and check. And if I run it again and my flashcards are ready, it'll tell you it's time to study and give you a URL. The code for this is, of course, very simple. It just uses net HTTP and JSON, and it provides a method. So given a particular API key, go to a URL, fetch a response, and if there's no error, looks at the data, and if you have reviews available, it says 0 seconds. Otherwise, it calculates how much time until your next review. And this was super simple, easy to test, easy to fit in my head. Importantly, though, it gave me the experience to work with WaniKani's API, and this helped solve one part of the larger application I eventually wanted to build. So the next weekend came, and for my next project, I felt a little bit more motivated, and I wanted to build the English to Japanese flashcard game, but that was too much, because it had a complicated user interface and it also had all these rules about how the game should work and how to persist progress. And I would never have finished it in one weekend. And so I carved out just the game logic. But it needed to be useful, too. And so what I did was I wrapped it in a simple throwaway command line interface. And it looked a little bit like this. And so for several weeks, I practiced. And I'd drive out the logic by practicing right answers and wrong answers, and found that I'd have a lot of synonyms, and so you'd make it safe for synonyms, and then it would store my progress and set up the timers and so forth. And because I knew I was throwing away the CLI, you can see that it's just a while loop. It's just using readline and puts statements. And so when you strip all that away, what you're left with was actually kind of interesting. I had real code to build a review queue for me. I had a way to score those answers that I gave it, and a way to persist my progress. So that weekend project was a huge success, and it became the actual code that now runs the current web application. So incremental accomplishment like that is really motivating, keeps you moving forward, and that's why the selfish programmer is unambitious. They have to shrink their dreams down until they're so easy to accomplish that they're certain to succeed. Now, next up, antisocial, stage 2. The selfish programmer is ungrateful of open source and understands that if dependencies are added carelessly, they may create an unmaintainable mess. So I like to, when I'm speaking about dependencies, envision applications like triangles, where at the top is the actual application code that we write, and everything beneath are all the gems and other things that we depend on. And at work, our systems are really large, so the marginal cost of adding just one more gem is very low. But when we're solo, our time is limited. And if we add too many gems, things like upgrades and workarounds eventually consume more time than we have to give the app. But arbitrarily limiting myself and saying I'm only going to use 2 or 3 gems, that wouldn't be much of a solution, because then our apps wouldn't be very useful. So what I've done instead is I started to categorize dependencies as I adopt them, based on how much I trust them and their maintainers. So for example, even though Rails is very large and installs 41 additional gems, I trust the Rails core team to carefully curate them, keep them up to date, and fix any problems for me. So my gem file, you can imagine, is split up into sort of 2 categories of dependencies. Smaller gems that I don't really trust the maintainer or know them, or maybe they're not updated very often, and if they break, I assume responsibility, I'm going to probably have to fix them. And larger gems where if something goes wrong, they're really popular, I can probably just wait a few days and get a patch. Now also, at work, I've been conditioned to never reinvent the wheel. That means writing your own code even when some other code could already do the same thing. But when I'm solo, I can choose to be ungrateful and write some code even if there is already a gem that claims to do this thing already. And so, for example, maybe a gem works fine, but it fetches the whole universe for just one more feature. And the gem's usefulness isn't worth the maintenance cost of 28 additional gems. Another problem is when a gem is too hard to learn or use, and if you get frustrated by a framework or library, that's one of the top reasons that people quit their solo projects, because they don't have additional help. So reinventing the wheel, maybe it's bad, but it's certainly better than quitting and giving up. For example, at work, I've never actually been responsible for building authentication features. I specialize in other areas. But for my solo app, I needed to be the one to figure it out. In the past, I'd tried and failed to use the devise gem, but I was so afraid that I was going to fail again that I was just worried about authentication, like how I was going to approach it. So instead, I just started with a super basic password field, and I installed bcrypt, and then I used Rails' has secure password feature, and I was surprised that it just worked. And that gentle climb was all I needed for the first 5 months of the application. Now, eventually, yes, I added additional stuff like custom features like changing your password and verification emails and resetting your password and so forth. And yes, those custom features are probably complex enough that I spent more time building them than it would have taken me to learn how to use Devise. And yes, I'll admit it did feel silly generating custom tokens and saving them and emailing them and handling verification links because I knew that Devise could do all of this for me. But I'm still proud that I did it myself this way because I understand my implementation completely and I didn't give up. So Kame-Same gave me a place to practice something that I wasn't comfortable with at work, so now I don't feel so stupid talking about authentication with other people. So you can try to solve every single problem by just Googling for gems to do things for you. But because dependencies are easy to install doesn't necessarily mean that they're easy to deal with later. And so that's why the selfish programmer is ungrateful. Whether at work or solo, it pays off to think more critically about the trade-offs of each dependency that we add. So next step, antisocial, stage 3. The selfish programmer is ungenerous and doesn't worry too much about making code reusable. At work, I was trained to share as much code as possible to be a good teammate. So whenever I added some code, I could have put it with the feature logic, but instead I often put the code where others would find and use it. And then I'd invoke it from my feature to just be a good teammate. But when teams all work this way by default, eventually, reuse can actually slow them down because perhaps a second feature adds more code to that model, and a third feature maybe reuses some of my code, and a fourth feature goes and reuses some of the other code. And after this, if a feature that uses some of the shared code needs to make a change to it, that change, of course, affects anyone else who calls it, and it might blow up. And so we have to be really cautious that every single call site of a shared method isn't broken by any subsequent changes. Additionally, you can imagine in a shared place like a model, maybe some of those internal methods call one another, and in fact, the usages of each of these shared places is so much that the cost of reusing code is much higher than we assume. So this is why I prefer to what I call soundproof my code. So instead of, by default, putting my code in shared places, I try to keep it as close to the feature as possible and implement it there and only extract it for reuse later if it seems like it'll be valuable. So as a result, most of my code tends to be pretty isolated and live on its own, and most of my models are just kind of simple, dumb value types that get passed in and out of features. This impacts how I divide responsibilities when I write code. So if you look at this controller, it does two things. It invokes a search as like feature code, and then it invokes like general utility code that just formats results. So I split these responsibilities to like soundproof the feature code and minimize the general utility code. So the feature-specific code is only called one time, which means that it can be changed aggressively, it can be ugly and gnarly because only one thing is using it. But the general purpose code, I need to keep really minimal because it's called in 7 other places, which means it's going to be a lot more work to change, and so I'm more focused on keeping it really lean and focused. Separately, I don't allow the models, like the word model, to actually have any feature logic themselves. I treat anything that's a Rails subclass as like a DSL for configuration only, and not a place to put my own custom code. Because if I add one method to word.rb, it'll still look really small lexically, but it'll actually be its 312th method, which means that the contract between it and whoever calls it is not really clear and explicit. But if I create a separate class with exactly one purpose, it only has one method, and so the contract between it and its callers is very clear. So soundproofing code has proven to really work for me. For over a year before Kame-Same existed, it actually started as an example sentence search engine called Sentence, and only later did I add Kame-Same on top of the exact same set of models, and it required 0 changes to Sentence, it just worked. Best of all, when I deleted Sentence, I didn't have to change anything at all, and nothing broke. So at work, code is often treated as a valuable asset, which makes people, especially managers, think that maximizing reuse will help people go faster. But the more places that call a function, the more careful our changes must be. And that's why the selfish programmer is ungenerous and not afraid to write a little extra code if it means gaining a little extra flexibility. So that's why it helps to be a little antisocial when we're programming by ourselves. And now I'd like to talk about the virtues of being egotistical. So World 2, Stage 1. The selfish programmer is delusional because sometimes it's necessary to believe that your code is good enough to ship even when it's still really bad. So this is the Kame-Same homepage, and it shows summary information about your progress, like your level and XP. And the data for this interface is provided by an HTTP API. And the original code for that API looks a little like this. As you can see, it performs a lot of queries for such a small response. Now at work, this code would have never passed a code review. Because once merged, the whole team collectively owns that code. So if there's any problems, the whole team's problem. And this just results in a higher bar for quality up front. But if you never create a branch, then you don't need to worry about pull request reviews. So because this is a solo project, I'm just pushing everything straight to master. So the selfish programmer is delusional, I say, because they choose to believe that features are ready as soon as they work. And if we try to perfect that code in advance, we'll only be guessing at what the ideal design and optimizations are. So instead, if we push messy but working code, we can take time and observe errors and bug reports and feedback, gradually improving the code's behavior as we learn. So over time, I found myself adding and subtracting and adding code to this feature, but nevertheless, resisting the temptation to optimize its performance. Instead, I waited some more, and after a long time passed without any changes, I could be confident that the feature's behavior was basically correct. So code never tells us that it's done, so I just choose to believe that once code no longer needs to be changed, then it must be right. And now that the behavior stopped changing, we can safely optimize it. So recall, this has a lot of queries, and I needed some way to gather this data with fewer trips to the database. So initially, you could imagine the architecture of this feature like this. At the top, you have lots of logic written in Ruby, which made it really easy to prototype and change. And lots of individual queries to Postgres, which made it really slow at runtime. So I spent a few hours, and I re-implemented the entire feature as 4 SQL views. Now Postgres is great at math and aggregation, so the SQL views do everything that the Ruby was doing, except faster. And because the behavior is finished, it's okay that it's uglier and harder to read, because it's unlikely to change again. Additionally, fun fact, Active Record can actually query SQL views just like any table. Just overwrite the read-only method to return true, and it'll stay safe. So now, the payoff. Here's all this messy code, and I can replace it with much simpler Ruby. The Ruby is now responsible for much less. And if you look at the code, the architecture is much simpler. Just a little tiny bit of Ruby calling to a more complex Postgres implementation. So even though the implementation is messy, it's conceptually much simpler. And predictably, that route is now much faster than it was before. So to recap, I recommend shipping code as fast as we can make it work, letting those changes simmer until we're sure that we've made it right, and then making it fast by pushing down that behavior to a faster layer. So at work, peer pressure to write good code has made me a bit of a perfectionist, but this results in me often future-proofing behavior and optimization without any real data to base my decisions on. So that's why the selfish programmer is delusional, believing that messy code is good enough to put into production so that they don't waste too much time guessing how to make it perfect. All right, so next up, egotistical stage 2. The selfish programmer is narcissistic because they ask only how an activity will benefit them before they decide how to do it. So at work, our large apps usually have lots of units and tests of those units that call them and assert a response. We also have full stack tests that interact with the integrated system and then verify that the whole thing works. And on a team, tests like this address several needs. First, full stack tests build trust that our app does what other people think it should do. Second, it creates a safety net, allowing us to focus on one area without worrying about breaking things. And third, tests express our intentions to our teammates to tell them what we mean by our code, especially later on. But these testing benefits are less valuable for solo projects. I mean, you determine the direction, so you don't need to prove to anybody that it works how it should. Apps are small enough that you can probably focus on one thing at a time without them. And when you're by yourself, there are easier, simpler ways to take note of your intentions. So because of this, I took an innovative new approach to testing with Kame-Same. I call it AI testing, and I'd like to demo it for you now. So here's a sped up recording of a full test run. A single test will wind through most of the important parts of the application, and if you've seen other browser tests, then you probably looks familiar. It's doing things like making a user, running some flashcards, creating a one-off lesson to learn another word, exercises the search, changes the name, changes the password, logs out, logs back in. And this results in decent code coverage for a full stack test. So when it succeeds, I'm somewhat confident that nothing is broken. The problem is that this test takes 3 whole minutes to run. And so I want to be able to push to master and then go about my business as fast as possible. So I wanted to cut this time down. So this is where AI testing really shines. What it does is first it looks at only the most recent code changes, and then it only runs the tests that are actually affected by those code changes. And finally, the browser-based tests actually dynamically adjust to only cover the affected area. So here's another example where you can see that we'll log in, but the test is going to focus on just the custom spelling feature. So it's going to exercise that and actually spend more time there than it normally would in a normal test run, because that's the code that changed most recently. And so, of course, coverage is much lower in this build, but confidence is still high because the test focused only on the areas where the code changed. And best of all, it cut down the test build time to just 20 seconds, so it was much faster. I wasn't sitting there waiting for it. But I should confess, however, that AI testing stands for average intelligence, and those videos were me just manually clicking on stuff while SimpleCov was running. So truthfully, I didn't write a single test for the entire application because I wouldn't have gotten a good return on my investment for them. Because the primary remaining benefit of testing in this solo application was telling me if the app works. But I've intentionally made the app so narrow and focused that I can tell manually very quickly if the app is broken. So on normal teams, good testing pays for itself very quickly. You invest in writing them, running them, changing them. But if you're building a feature on a team, maybe you run it locally and then in CI, but maybe your teammate runs it locally and then they have their own changes. And then additionally, master CI once it's merged. So even by the time it's merged onto master, it's probably already paid for itself. But when I'm solo, the investment cost is similar. I still have to build and run and fix these tests. But I'm only running it locally a couple of times, and I'm running it once in master. And sure, it might pay off someday, but at least initially there's a gap there. And the payoff is not as obvious for writing a lot of automated tests for a solo app. So most activities that we as programmers that we do to try to deal with software problems can be categorized as either trying to maximize MTTF, or mean time to failure, the time between basically us preventing problems from occurring in advance, or minimizing MTTR, mean time to repair, fixing things when they do break. And it's probably important to try to balance our skills in these two areas. But for me, I've spent most of my career focused only on maximizing MTTF. That means I rely a lot, normally, on tests, compilers, and linters to avoid production issues. But by not writing any automated tests, Kame-Same has given me the chance to improve my skills at monitoring servers and analyzing logs and debugging problems when they happen. And so it's easy to assume that testing is always right and always worth it. But when you're solo, because it's your time that you're investing, you should be more judicious. That's why a solo programmer is narcissistic, deciding how spending time is going to benefit them. And once I did the math, I stopped feeling guilty for not writing tests because I understood that it wasn't worth it in this case. Okay, egotistical, stage 3. The selfish programmer is domineering because they're used to saying no a lot. Most people, they agree, great software requires clear, narrow focus and vision. But that means telling people no a lot. And telling people no is really hard. So when you're solo, you're not just the only developer and the only tester and the only marketer, you're the only product owner too. And being a product owner is a really hard job. Because at work, product owners have to juggle so many different stakeholders like marketing and finance and security and support. And of course, the needs of the app itself. So that means it's their job to prioritize how they do things. And it's going to make some people happy, and it's going to frustrate other people. So I decided to solve this early on by releasing Kame-Same for free. So as of today, we have about 2,300 users. But because it's free, Kame-Same has only one customer, me. So I have 0 other stakeholders, and that makes it much easier to decide what to do and what my direction should be. It makes it a lot easier to say no. And as product owner, I knew exactly what features I wanted at first, but after launch, I started gradually running out of good ideas. And so what I did was I went to WaniKani's message board and I started a thread, and you can see it's really long, but it's full of ideas, feature requests that people have posted and bug reports. So the way that I think of it is I give Kame-Same away for free, and people give me their ideas for improvement for free in return. And so, of course, if you go and read that thread, you'll see me saying no, politely, to people a lot. But honestly, if a feature doesn't appeal to me, Kame-Same's only customer, I probably don't want to spend a lot of time implementing it. But then sometimes I'll get messages like this one. It was from a colorblind person who said that the color coding for kanji and vocabulary was too subtle and resulted in too many accidental mistakes. But selfishly, I'm not colorblind, so I wasn't sure whether fixing this would benefit me, and so I decided to look closer at it. So for context, this is a vocabulary card asking for a multi-character adjective, and this is a kanji card asking for a single kanji character. Now, if you desaturate them, you can see how visually similar they are. And the solution was actually really easy, so easy that it was a no-brainer to do it. You can see that we are already checking for empty answers and making sure that people don't enter in Roman characters. We're already checking actually if kanji answers were completely just kana, like hiragana and katakana. And so the solution was just to add one more check, which is to make sure that the length of any answer for kanji was only one character. And then I updated the message. So you can see this actually catches this person's problem now, where if they type in a multi-character response, they'll say, oh, we're only expecting one kanji, and then they can fix it without getting marked incorrect. So even though this feature's inspiration was based on somebody else's problem, the improved validation has actually helped me many times too. In fact, most of my favorite features in the app were now somebody else's idea. So at work, it's easy to shut up and just blindly follow orders. But the selfish programming is domineering because they have to control their own priority and direction. There's no one else giving it to you. And at work, it can be uncomfortable to challenge a requirement that somebody else gives to you. But I've found that teams that struggle and debate over their direction, they end up writing better software. So today, it's not enough, though, to be antisocial and egotistical. The selfish programmer is also irresponsible. And I mean it literally. I don't want to be responsible for anything. All right, so World 3, Stage 1. The selfish programmer is untethered from operational responsibilities. Their apps need to be able to run themselves so that they're able to go and do what they want to do. So most apps, they have lots of operational work that doesn't really have anything to do with the app itself. Stuff like security, performance, upgrades, and monitoring. Now, originally, the term DevOps meant developers responsible for their own app's operations. And the idea was, well, like we saw with testing, if developers own operations, they'll simplify and automate it so that they can then go back to focusing on development. But that isn't what happened. Instead, DevOps was co-opted by large cloud providers who market increasingly complex, customizable services. And this has created so much new work that companies now hire full-time DevOps people, just like they would sysadmins. So because the definition of DevOps has changed, I am now a no-ops advocate. I want to focus on programming, so my goal is 0 routine operational work. And to reduce my app's operational costs, my first step was to do things like minimize dependencies, follow conventions, reduce the number of runtime services that my app needed. But this only helped a little bit. What I really wanted was for somebody just to take care of operations for me. I wanted to be able to walk into a store, buy some ops off the shelf, and then not have any custom setup. Fortunately, that store exists, and it's called Heroku. And not only is Heroku still good, it's better than ever. By helping me be irresponsible of operations work, Heroku actually captures the original spirit of DevOps. And this tiny file is all I need to tell it how to run my server and that it should run my migrations when I push. And I only pay $7 for the app and $9 for all these add-ons like Postgres and Bugsnag. But easily my favorite feature are deploy pipelines and review apps, where if I go in and I make a change to the code, like here, change a background from a white to purple, and I commit it to a branch, and then I go and I create a pull request. As soon as I create that pull request, Heroku starts provisioning a new application that you see over to the left. If I click it and I open up that application, the review app is now like a one-off staging environment that shows only the changes of that pull request. And it's really great. So to set up review apps, you just need a small JSON file, tell it what build pack to use and which add-ons to install, and give it a script to run. And that script, in my case, is real simple. It just says, hey, run my migrations, download some sample data, and then create a sample user. And that's it. That's really awesome. I've seen companies invest millions and millions of dollars into DevOps custom infrastructure and fail to match the developer experience of a $7 Heroku dyno. It's a really great feature, and I hope that you check it out. But most companies are going to resist no-ops, as well as platforms like Heroku, because it's really hard to admit that you're not a special, unique snowflake. And while it's true that no two apps are the same, it's probably true that they share a lot of common operational needs like hosting, deployment, and security. So why not outsource that stuff to somebody who specializes in it? And so that's why the selfish programmer is untethered by operations. They'll go further faster by focusing only on what they really want to do, which is write software. All right, irresponsibility, stage 2. The selfish programmer is fickle because solo work is a creative outlet, and so their opinions tend to change frequently. So at work, everyone brings their own perspective and coding style. And on some teams, everyone just codes their favorite way. This might make people happy at first, but inconsistency can lead to confusion and conflict later, which slows the team down. And ultimately, some things, even things we care a lot about, don't really matter. And code formatting is one example. So that's why some teams work to normalize on one style. They'll pick it, they'll decide on it, and then everyone else will try to do their best to follow one style. And the result is hopefully more consistent code that's easier to maintain over the long term. But one of the joys of coding solo is that your way is the only way. You're finally free to write code however you want. Except when I'm solo, I'm also really fickle. My favorite way to code changes all the time. And whenever my style changes, my code becomes inconsistent. So over time and across repositories, it actually makes it hard for me to maintain my own projects. So that's why linters and formatters like RubyKaigi exist, because they enforce consistency. But the problem with tools like RubyKaigi is each individual project will eventually create a large custom style configuration. And any time spent configuring or arguing about this is just wasteful bike shedding. And since every project is going to have a different configuration, we're going to waste precious brain power just keeping all these styles in our head at once. So that's why at TestDouble, we created Standard. You just install the gem, and then it wraps RubyKaigi with a single configuration that's actually locked inside the gem and cannot be customized. So the CLI is also really simple. You just run standard RB, the binary, and you can add the option fix to have it automatically fix things. And trust me, this is not Justin Searls style. Standard is the result of a lot of compromises. This is actually how I like to write Ruby code. But for example, standard enforces colons instead of hash rockets, trailing commas in array literals and hash literals, space inside of blocks, and leading dots instead of trailing dots on method chains. So now I write Ruby like this, and I don't love it, but I value the greater consistency. So if you adopt standard, our hope is that you can maintain consistency without worrying or arguing about every little rule. Additionally, if your team adopts it and you don't like something, you can blame the tool instead of one another. So the selfish programmer is fickle, and opinions about unimportant topics that, they change over time. So sometimes it's better to rely on a tool to help us stay consistent and focused. Okay, the final stage. The selfish programmer is unhelpful. They'd rather solve problems once and for all than keep solving the same problem over and over again. So at work, developers are often too far away from users. Customer support might sit between them, and support is probably the first responder to lots of issues. And if they don't know how to solve something, they might go and ask the developers, who might just give a simple workaround, hand it back, which then goes back to the user. But if another user has the same problem, they'll ask support, and the support, knowing that developer time is expensive, will probably just repeat the workaround as many times as users have that problem. And I see this enough where what happens is the developers are actually insulated from the feedback of what the real problem is, and this can just create a lot of waste. But when you're solo, you're exposed to everything. Every email, every tweet, every error. And because I hate these notifications, I'm willing to spend lots of time to make them go away. And so, for example, I once had a time bug where it wasn't caused by time zones or data types, but by the actual passage of time. You see, I had a controller eventually grow to serve two purposes. And so I split this private API into two more focused controllers, and then I deleted the original route. And the moment that I deleted that file, even though nothing else called it, I started receiving dozens of bug reports. And when I learned that some people never refreshed their browser tabs, what was happening was they'd load the page, and then I'd change the server, and then their browser would keep on hitting that route, which caused the bug. And I can't believe this. I was still receiving this bug report 6 weeks later. So that's how long people keep tabs open. So clearly, I need to update the client first and leave weeks of time for JavaScript changes to propagate before I change the server. But for a solo project, how should I do that? I could write a to-do message to myself, like delete this later, but that never works because of LeBlanc's law, which states that later equals never. So I'll forget about that comment and never delete the dead code. So I spent a couple hours writing a gem called To Do or Die. Its name is based on an old US Famicom game. And it's a single method which takes a comment and a due date. So this plan is to delete this code by June 2019. And when June comes, if I try to start my server, To Do or Die will raise an error telling me that my to-do is overdue and where to find it. But in production, we don't want to impact users, and so it'll detect that you're in production and just log a warning instead. So even though To Do or Die took some time to create, since I started using it, I've never seen another bug report that's similar to this one. So that's why the selfish programmer is unhelpful, because they understand that if nobody is bothering them, it must mean they did a good job. So that's a bit about how a selfish programmer is antisocial, egotistical, and irresponsible. And if you have any comments or questions, I hope that you'll tweet at me or send a DM today. I'll also be here all day, and I'd love to talk to you. If you want to check out the app, it's at kamesame.com. And you can also get a free copy of all this background artwork at this URL here. If your team needs developers, and you don't mind if those developers speak mostly English, I'd love to talk to you about my company TestDouble today. And in closing, I hope that this talk made you consider to be a little bit more selfish when you're practicing your solo coding. And I just want to thank you very deeply for joining me today. And we don't have time for questions. 0 time. Oh, right, because in Japan, this circle is yes. So if anyone has a question, just bring the lights up and run to a microphone. It's probably turned off. Click the...
Okay.
Yeah, hello.
Yeah, thank you very much for the presentation. I like it a lot. I like your story and motivation for creating the application. So my question is, because I'm not actually a programmer, I'm a learning scientist and instructional designers, I feel that what you've done, the story, is quite good for training the programmers, how to be practical, how to make things done, and this how to think about this idea. Because you're creating some for learning Japanese, you're creating your applications. Do you get some idea for using these stories, using the principles you create for make a training program for the programmers?
Yes, thank you for your question. I think that in general, I don't have a lot of advice for beginning programmers because it was a long time ago, and all I can do is teach people how to be really bad at programming for their first 10 years.
Yeah.
But what I will say is that the best way to learn how to program is to find something you really want to exist and force it and just do all the work that you need to do to make it happen. So thank you very much for your comment. I appreciate that.
Thank you.
Mike, over there.
Hi, great talk. My question was, you talked a lot about the difference between working solo and working kind of on big proper workplace projects. How do you see almost open source sit on that kind of spectrum in terms of the work you do?
I think, and Mike maintains Homebrew, which we all use, so thank you, Mike. I think that you probably know well that maintaining a library is very different from maintaining an application, especially an application that is a live running service with real users. And so a lot of the things that I've been doing open source for over 10 years that I thought would be easy was based on running like a simple library or a gem, that when running like a live running server application just forced me to change a lot of my priorities. And so for me, this was a fun experience. It was definitely a lot different than I expected.
Thank you.
Thanks. All right. Yes.
Thanks for the amazing talk. My question is this model, selfish working, sustainable? Because if your project becomes successful, it eventually is no longer a personal project anymore.
No, that's true. So if you plan on hiring people or growing and you get famous, hopefully, you'll be able to spend the time to do things like, in this case, I guess I'd go back and write enough tests to feel comfortable. One of the things I've learned is that if I get famous, I'll worry about that when I'm famous, and I'll have all the fame and money to solve that problem later. But if I worry about it initially, it'll just paralyze me and prevent me from doing the simple thing early on. Yeah, in the back.
Do you have any solutions for trying to deal with manually testing like you were doing, but when you're working on a really complicated feature that may have a lot of edge cases, if you're not going to be writing automated tests, how do you go through and kind of figure out how to run all that?
Well, I didn't create a law that said I will never write a test. I just said it doesn't seem worth it yet. And so if I had a particularly thorny case, even if it was just one feature, just one test of one little part, I'd write it because it would save me time. It's just about making that value determination for myself.
Thank you so much.
All right. Probably good. Thank you so much. 本当に感謝します。またね。